this just in case you didn't figure out how to do this or whatever, but I already covered how to run the test and find the test statistic and the p-value, but I wanted to talk about critical values on a student t distribution curve. And let's just assume I want this critical t value here. So I'm on a hypothesis test. It's a left tail test. Alpha was 0.05, and so I need the critical value here corresponding to that, right? So if you're looking for a critical t-score anyway, or a t-value corresponding to an area on a student t distribution, you're going to go second vars, just as you would to find a z-score, but you're not doing inverse norm like you would for z-score, you're doing inverse t. And so it's asking for area, and the area that you input is always the area to the left of the value that you want. So in this case, because this is a left-tailed test, I already know that area. If it were a right-tailed test, I would just say 1 minus, okay? So you're always inputting the area to the left here of whatever value that you want, okay? That's what the calculator's taking. So this area is always whatever area is to the left of the value that you want. So if it's directly in the left tail, easy peasy. If it's in the right tail, do the 1 minus. Degrees of freedom, you guys know how to find, so it needs that too, and then paste, and this is how you find your critical t values. So, I don't think we do a lot of critical t-scores when we do confidence intervals, but we do need them obviously for hypothesis testing. So again, it's very similar to finding z-scores, just like we did, on a standard normal distribution curve. How do you find a z-score if we know area, inverse norm? But now it's a t-score, so second vars. How do you find a t-value with a given area, inverse t? But obviously now you need degrees of freedom, and you need the area, and there's no option to tell it where the area is, so automatically you have to input area to the left. And that's it, it'll give you your critical t-score.